Welcome to this video. Here I'll be starting to solve this 1985 AP Calc BC exam, the multiple choice portion. And I'll give my disclaimer as always that I'll leave it up to you to check whether the content in this exam is relevant to what's taught in BC now. Okay? Now meaning whenever you're watching this video. I'm assuming you're a student of BC Calculus, okay? There might be topics that aren't covered anymore, or there might be topics that are covered that actually aren't in this exam. So I'll leave that all up to you to figure out. Okay, I was just going to be solving the problems. All right, so let's begin. Area of the region between the graph of y is 4x cubed plus 2, and the x-axis from 0 to 1 is, this is very easy because it's just the integral from 1 to 2, 4x cubed plus 2 dx. When talks integral is area under the curve with respect to x-axis. So we integrate this guy from 1 to 2. Okay? So this is, we just use power rule, x to the fourth plus 2x. Evaluate from 1 to 2. That's what, 16? 2 to the fourth is 16? Yeah. Plus 4 minus 1, parentheses 1 plus 2. That's what, 20 minus 3, 17. I believe it's D. Let me double check. I need to pull up the key real quick. Yep, that's correct. Okay. At what value of x does f of x equal 3x to the 5, fifth power minus 5x cubed plus 15 have a relative max? This should signal to take the first derivative and do the first derivative test. Okay, sorry the video jumped. I was looking to see if this one I solved in the AB exam, but it looks like I did not. And it doesn't look like there's any matching problems. Maybe there will be, and I'll come up later. But anyway, I'll just solve it again, even if I did solve it. So this one, as I was saying, relative max, we should probably find the first derivative of this guy. Okay, so f prime would be what? Power rule, that would be 15 x to the fourth minus 15 x squared. Okay, derivative of 15 is 0. Okay, let's set this equal to 0. 15x squared, we can factor out to be x squared minus 1. Okay, and so it'll be 15x squared, x plus 1, x minus 1 is equal to 0 if you factor out. So our critical points are x is negative 1, 0, and 1. Let's do our first derivative test. Okay, we plug in some huge negative number into here. This is always positive, so we can ignore. Huge negative number plus 1 is negative. Huge negative number minus 1 is negative. Two negatives make a positive. Plug in some number in this interval, like half, negative half, that's here. This would be positive. This would be negative. The sign is negative. Plug in like positive half. This would be positive. This would be negative. So, negative. Then we plug in a huge positive number. This would be positive. This would be positive. Positive. So what is it asking? It's asking whether there's a relative max. So that's when the derivative changes from positive to negative. That's at x is negative 1. Let me double check that's the answer. Yes, negative 1 only. Okay. This one, x plus 1 of x squared plus 2x dx, this integral, I see that we can make a substitution. I feel like I did solve this. Maybe it was not in this, the 1985 exam, but maybe a different year. But anyway, let me do it once again. Give me 1 second to get this piece of scratch paper. Let's let u be x squared plus 2x. du would be 2x plus 2 dx. Okay? And actually, we can write it as half du is x plus 1 dx. Multiply half on both sides. Okay? So why do we want to do that? Well, because there's x plus 1 dx there. Okay? So we can rewrite our integral as, let's worry about our limits right afterward. It'll be x plus 1 dx, that's du over 2, or half du over u. And limits of integration, when x is 1, u is 1 plus 2, which is 3. When x is 2, u is 2 squared, which is 4, plus another 2 squared. So 4 plus 4, that is 8. Okay, so this is L half times ln 8 minus ln 3 after fundamental linear calculus. Okay, so this is B. 3 is B? Yes. Okay. Particle moves on the xy plane so that at any time t, its coordinates are x is t squared minus 1, y is t to the fourth minus 2t cubed. At t is 1, its acceleration vector is what? Okay, so this is the position vector, so we can call that what? S vector is equal to t squared minus 1, t to the fourth minus 2t cubed. Okay? Then the velocity vector, we just differentiate each component. 2t, and then 4t cubed minus 6t squared. And then the acceleration vector, we differentiate the velocity. It would be 2 and 12t squared minus 12t. When t is 1, then a of 1 would be 2 comma 12 minus 12. So it'll be 2 comma 0. 4 is D, yes. Okay. Oh, I don't know if I got cut off, sorry. So this is the acceleration vector, and then we plug in t as 1. Okay, let's move on. The curves y is f of x and y is g of x is shown in the figure above. Intersect at the point A, comma B. The area of the shaded region enclosed by these curves and the line x is negative 1, that's what they show here, is given by which of the following integrals, okay? Can I squeeze this in all in one in the screen? No, okay, that's okay. So area is upper curve minus lower curve. So it should be f of x minus g of x from negative 1 to a if it's with respect to x. So 5 is D. Okay. Hopefully, this should be easy because to find area between two curves, upper curve minus lower curve. So that's f minus g in this case. The limits are from negative 1 to a because we take the limits in with respect to x. Okay? If f of x is x over tangent x, f prime of pi over 4 is what? Well, to find f prime, we can use the quotient rule. It'll be bottom d top, so bottom d top derivative of x is 1 minus top d bottom derivative of tangent is secant squared over bottom squared. Okay, let's evaluate this at x is pi over 4. Then that is equal to what? Okay, tangent of pi over 4 is 1, right? Minus pi over 4. Let's secant squared of pi over 4. That would be half, right? Because that's not right, sorry. Oh, it would be 2. Because secant of pi over 4 is root 2. So yeah, this would be 2, sorry, over tangent squared pi over 4, so that's 1. So it should just be 1 minus pi over 2. Is it E? 6E? Yes. Okay. Let's move on. Which of the following is equal to this guy? This guy I can easily see it's a trig sub because it's something squared minus something squared. Okay, so let me do that. So if you remember, if you saw my crash course to trig sub video, I always set up a triangle first. This is something squared minus something squared, so I know that this first term is the hypotenuse, so 5, x is one of the sides, and the square root term is the last side. Due to Pythagorean theorem, this should work out. So let's substitute everything in this integrand in terms of theta. We need dx, so we need to get x first. X is what? Well, sine theta is x over 5, so 5 sine theta is x. So 5 cosine theta d theta is dx. We need to substitute the square root term. So we can get that by what? Cosine theta is square root term of 5. So 5 cosine theta is square root term. Okay, so we can rewrite our integral as dx is 5 cosine theta d theta. Square root term is 5 cosine theta. Okay, so this is just integral of d theta, which is just theta plus c. What is theta? Theta, we can just use our definition here, would be arc sine of x over 5 plus c. Okay, so 7 looks like is A. Yes. Okay. If f is a function such that limit as x approaches 2 of x minus f of 2 over x minus 2 is 0, which of the following must be true? This looks literally like the derivative. Okay, so maybe we need to do that. Or maybe it's C right away. Yes, the answer is C. Okay, so you just recognize this is derivative. As simple as that. If xy squared plus 2xy is 8, then at the point 1, 2, y prime is what? Here we just need to implicitly differentiate. So let me do that. Here we need product rule. Oh, it would be first d second, so first d second times dy dx plus second d first derivative of x is just 1. This guy, we again need product rule. It would be first, we can lump the 2 with the x. First d second plus second d first. Derivative of 8 is 0. Okay? So this is what happens when we differentiate both sides. Now let's solve for dy dx, or y prime, same thing. Okay? So let's move this term and this term to the other side. So it'll be 2xy dy dx plus 2x dy dx is equal to negative y squared minus 2y. We can factor the dy dx. Let me just do it in multiple steps. Okay, then we solve for dy dx. Okay, now we evaluate it at the point 1, 2. Okay, so what do we get? We get minus 4 minus 2 times 2, that's another negative 4, over 2 times 1 times 2, that's 4, plus 2 times 1, that's 2. So this is negative 8 over 6, which is negative 4 thirds, sorry. Is that the answer? 9b. Let me check. 9b, yes. Okay, I suppose that implicit differentiation. Okay, here's a series problem for negative 1 less than x less than 1. This maybe is the interval of convergence, maybe? I don't know yet. If f of x is this guy, then f prime of x is equal to what? Oh, this is easy. This is this is a power series, so we can differentiate the inside of it like normal, okay? The thing here, the confusing part is probably this negative 1 and to the n plus 1 power. That doesn't depend on x, so we can treat that as a constant, okay? And this guy we can treat as a constant also. So, okay, let's do d by dx of, since these are constant, we can just multiply it back at the end. So of x to the 2n minus 1 power. This is, we just do the power rule. It'll be 2n minus 1, which is minus 2. Oh, sorry. Power rule, we bring it down first, so 2n minus 1. X to the 2n minus 1, minus 2 there. Okay? And then, yeah, that's fine. So let's multiply this with minus 1 to the n plus 1 over 2n minus 1. Let's multiply it with this, what we got here. So times 2n minus 1 times x to 2n minus 2. This and this can cancel, so we are left with negative 1 to the n plus 1, x to the 2n minus 2. Okay? 10 is 8. That's exactly what we got. All right, let's move on. This guy, we find derivative of this guy. This is easy. Chain rule and then quotient rule, maybe. Or we could even write this as d by dx of log of 1 minus x to the negative 1 power, if we really want, okay? So we just got to be careful with the chain rule. Okay, so we first do derivative of log, which is 1 over the argument, so 1 minus x to the minus 1, times derivative of this guy, which is times minus 1 times 1 minus x to the minus 2 power, times derivative of the inside of that, which is negative 1, okay? So this we can cancel with this. This we can move up to the top. This we can move up to the down to the bottom. So it'll be 1 minus x over 1 minus x quantity squared, which is just 1 over 1 minus x. 11 is A. Okay? This guy, we need to use partial fraction decomposition. I can see it right away. Hopefully, you're able to too. Okay? This is the simplest case. We can break it up as, so this we can break up as a over x minus 1 plus b over x plus 2. Multiply both sides by this denominator, so we get 1 is equal to a times x plus 2 plus b times x minus 1. We can start plugging in easy numbers like x is negative 2, because this equation has to hold true for all x, so even for x is negative 2, you get 1 is equal to, this would go away, this would be negative 3b, or b is equal to negative a third. When we plug in x is 1, this would go away, so 1 is equal to 3a, or a is equal to a third, okay? So we can rewrite this integral as a over x minus 1, where a is a third, so a third times 1 over x minus 1, okay? And then plus b over x plus 2, b is minus 1/3, so minus 1/3 times 1 over x plus 2, all by dx. So these are easy to integrate, they're just both logs, right? So it'll be a third log of x minus 1 minus a third log of x plus 2 plus c, okay? We don't quite get one of those, so what can we do? Well, we can combine these two logs into one, okay? And how do we do that? Well, the long way is you can put this, the way I see it is you can, let me do it here. You can move the coefficient in the front of the log back as an exponent. Okay? And then remember the difference of two logs, you can do it as the ratio. Okay? So it'll be x minus 1 to 1/3 divided by x plus 2 to 1/3, or I can write it like this, okay? And then we can pull that back out front. Okay? So that's how we get A. Okay, so that was just lots of tedious math. Properties of logs. Okay, next, I'll probably finish the problems on this page and call it apart. Let f be the function given by f of x is x cubed minus 3x squared, where all values of c such that the conclusion of the mean value theorem of differential calculus, the closed interval 0 to 3. Okay, so I'm like, what is c? But they assume that that all books use the variable c for mean value theorem. Okay, what does mean value theorem say? F has to be differentiable. That's an important condition. We know that this is differentiable because this is just It's just a polynomial. Okay, polynomial is differentiable. Okay, that's an important initial condition that has to be met. Okay, the mean value theorem says since it's differentiable, then there exists some value in this interval between 0 and 3 such that f of 3 minus f of 0 over 3 minus 0, the average rate of change is equal to the derivative at some point, where c is, it won't be exactly probably, but I forget if it's inclusive, but it'll be in between 0 and 3, okay? That's what mean value theorem says. So how can we do that here? Well, we can first do this side of the equation. So f of 3 minus f of 0, what is that? That would be 27 minus 3 times 9, that is 27, I believe, right? Yeah, so it's 3q minus 3q, that's, okay. Minus f of 0, that's just 0. Okay, so we want some f prime of c, which is 0. Okay. So what is f prime of c? Well, f prime of x is just parallel. It'll be 3x squared minus 6x. Okay, we set it equal to 0. Okay, so let's factor a 3x. So that would be what? X minus 2. So x is equal to 0 and 2. Okay, as I said, it shouldn't include the endpoint. So it should be 2, x is 2, or c is 2 for that. Let me see what the key says. 13b, yeah. I don't think it includes the endpoint. I mean, sorry, the endpoints. Okay, so you can double check on that. But the key says the answer is B, and that's what we got, right? The only question was if it should include 0, and I don't think it does because I don't think it's inclusive, but you can double check that. Small detail that I don't remember that might be critical. Anyway, which of the following series are convergent? Okay, so this is the same thing as summation of 1 over n squared. I'm not going to write the limits, okay? This is the same summation as 1 over n. It's convenient that they give us it, right? And then this is summation as of minus 1 to the n plus 1 over 3 to n minus 1, okay? So we know this is convergent because this is a p series where p is equal to 2. This is divergent because this is the harmonic series, okay? Now what about this one? Can we use the alternating series test? Because 1 over 3 to the n minus 1, this is a decreasing series, right? Sorry, decreasing sequence. So the alternating series condition is met, and the limit as n goes to infinity, 1 over 3 to the n minus 1. As n gets bigger, it'll be 3 to infinity. Excuse me. 3 to infinity is infinity, so 1 over infinity is equal to 0. So by the alternating series test, this should be convergent also. So it should be 1 and 3 only. Okay, good. Last problem for this part. If the velocity of a particle moving along the x-axis is v of t is 2t minus 4, and if t is 0, if at t is 0, its position is 4, then at any time t, its position x of t is, this is just talking about solving the antiderivative given the initial conditions of a particular solution. Okay, so let me finish it off on this page. So v of t is this. So x of t, I just said, is the antiderivative, or the integral of v of t dt, which is the integral of 2t minus 4 dt. This is just simple power rule. It'll be t squared minus 4t plus c. This is x of t. Okay? They give us x of 0 is 4. So x of 0 is 4, which is equal to, we plug in 0 wherever there's a t. So c is equal to 4. So x of t is t squared minus 4t plus 4. 15 is c. Okay, I'll stop here for this part. Hopefully this was helpful. Please give this video a like if it was helpful, and please subscribe to the channel to look up for the next part.